Hello students, previously lesson 5 from 2 to book 2 we were dealing with the reaction of alkali metals with water. So today lesson 6 we are going to start with electropositivity. So what is electropositivity? This is the tendency of an atom to donate or to lose electrons and form positively charged cations. Remember we said in ion formation atoms or metals lose electron, and when they lose electron, they form cations or positively charged ions. The electropositivity of alkali metals increase down the group. So this is a trend in electropositivity of alkali metals. Reason, this is due to the increase in the easy losing electrons as the atomic size or as the size of atom increases down the group. We know the size of the atoms of alkali metal increases down the group because of the increase in the number of occupied energy levels. So as the number of occupied energy levels increases down the group, that means the easy losing electron also increases down the group, thereby increasing now the electropositivity of alkali metals. So example, we are told potassium is more electropositive than sodium. Why? This is because potassium has large size, hence has a high tendency of losing electron. Then sodium, which has a small size, hence has less tendency of losing electrons. So we say, remember, electropositivity is the tendency of an electron to lose or to donate electrons. So the one that has the highest tendency of losing electron becomes more electropositive than the ones that has the least tendency of losing electrons. So number 5, we are going to go to reactivity of alkali metals. So the reactivity of alkali metals increases down the group. That means lithium and sodium is more reactive. Then sodium and potassium is more reactive. So reactivity of alkali metals, they increase down the group. So reason, this is due to the increase in the easy losing electron as the size of the atom increases down the group. Here the same. An atom of alkali metal, if it has the highest tendency again of losing electron, that means it's having high reactivity. So reason for this trend is that due to the increase in the easy losing electrons as the atomic size or as the atomic radius is increasing down the group. So example, we are told sodium is more reactive than lithium. Yeah, reason, this is because sodium has large size, hence has high tendency of losing electron than lithium, which has a small size, hence has less tendency of losing electron. So that means electropositivity and also reactivity of alkali metals are just the same. They all talk about the tendency of losing electrons. So the more the atoms loses electron, the more reactive the atom is or the element is. You have to know that. Next, we are going to go to similarities of ions and formula of some alkali metals. So here we have alkali metal ion, lithium ion, sodium ion, and potassium ion. Here we have hydroxide ion, here we have oxide ion, and also chloride ions. So here you are given one, that means potassium reacting with hydroxide ion. So it's written KOH. The reason why they are writing here is we know the valency of alkali or potassium is 1, and the valency of hydroxide ion is also 1. Hydroxide is a radical. What have you said about radical? Group of atoms with a net charge that react and exist as a whole unit during chemical reactions. So if we interchange now the valency, we are going to have K1OH1. So we don't write 1, so we just write KOH. So if you write potassium hydroxide like that, even lithium hydroxide and sodium hydroxide will be just similar because they have all of them a valence of 1. Okay, so that means what you're supposed to do, only you change the chemical symbol for potassium to lithium, and the chemical symbol for lithium is a Li, so you add OH. That's how you write lithium hydroxide. Then sodium hydroxide will be NaOH, and the reason is, check, sodium is written a valence of 1, hydroxide is written OH, valence of 1. If you interchange, it's going to become like that. Okay, we go to oxide side. We are given an example on the side of sodium oxide. Remember, sodium is having a valence of 1 because it's an alkali. Then oxide, that's oxygen, has a valence of 2. So if you interchange, it will be 2, 1 like that. So to write the formula, it will be Na2O1. So we don't write that one. So this will be similar when you're dealing with lithium oxide and also potassium oxide. So you only change the chemical symbol for sodium, then you write the chemical symbol for lithium to write lithium oxide. So, and the same will happen on the side of potassium. So to write potassium oxide, it will be K2O. Potassium has a valence of 1, oxygen has a valence of 2. The 2 will go this side. Okay, next we are going to go to that side of chloride. Here we are having lithium chloride. Remember, lithium has a valence of 1. Lithium has a valence of 1. Then chlorine has a valence of 1. So if you interchange now, it will be 1 to 1. So that means it will be LiCl. So the same will happen on the side of sodium and also potassium. So if I want to write sodium chloride, it will be NaCl. The valence of sodium is 1, the valence of chlorine is 1. If we interchange, we still have 1, 1 there, which we are not going to write. Then the same on potassium chloride, KCl. So potassium has a valence of 1, chlorine has a valence of 1. When you interchange, we are going to have K1Cl1. So we don't write 1 in that side. So we are going to write KCl. So next, we are going to go to uses of alkali metals and their compounds. So we're starting with number 1, sodium. Sodium is used in the manufacture of sodium cyanide for use in the extraction of gold. Okay, number 2, lithium is used in the manufacture of special high-strength glasses and ceramics. Then number 3, we're having lithium compounds are used in the manufacture of dry cells for use in mobile phones, laptops, and also stopwatches. Number 4, a molten mixture of sodium and potassium is used as a coolant in nuclear reactors. Then number 5, we're having sodium vapor is used to produce the yellow glow in street lights. Number 6, we're having sodium chloride is used as a food additive. Number 7, molten sodium is used as a reducing agent in the extraction of titanium from titanium 4 chloride. And we're given the question for that. So here we're having titanium 4 chloride plus molten sodium giving us titanium metal or solid. Here we're having sodium chloride. So we are done with alkali metal. That's the end of our lesson.